Okay, here are three key properties of logarithms. The first one says if you have a multiplication problem inside of the logarithm, then that turns into the addition of the two different logs. If you have a division property inside of your logarithm, that turns into the difference of two separate logs. And if you have a power within your logarithm, the power can come out front of the log and be p times that log. Now, you all know your properties of exponents. You know, for example, x to the second times x to the third is equal to x to the fifth. When you're multiplying exponents, multiplying bases, you add exponents. Here, when you multiply inside the argument, you add logs. If you had x to the seventh divided by x to the fourth equals x to the third, you're dividing x's, but you subtract exponents. You're dividing inside the log, you end up subtracting the logs. And if you had something like x squared all to the fifth power, you would have x to the 10th. Well, if you have a power being raised to a power, you multiply exponents. Here, your x is being raised to a power, you multiply times the log. So it's very consistent with the properties of exponents because we're dealing with the inverses of exponents, namely the logarithms. Okay, we now want to apply these properties. Notice inside the parentheses we have 49k. That's a multiplication problem. So we can split that into addition of two logs. We can have log base 7 of 49 plus log base 7 of k. Now, this log base 7 of 49 can be simplified because 7 to the second power makes that 49. So this is going to equal 2 plus log base 7 of k. In this next problem, we have division inside of the logarithm. That will turn into subtraction. We will have log base 9 of m minus log base 9 of n. Be careful that you do write it this way. A very common mistake, and this is a not equal to, is to turn that into log base 9 of m divided by the log base 9 of n. You do not want to go there. If you have division inside the log, you split this into subtraction. If you have two separate logs being divided, that's just two separate logs being divided. You do not have a property to simplify that one. Okay, in this next one we have another division problem which is going to turn into subtraction. We're going to have log of 1000 minus the log of c squared plus 1. Now, we mentioned earlier that the base of a common log is 10. And 10 to the third power makes 1000. So this first logarithm is equal to 3. And we're going to have 3 minus the log of c squared plus 1. Now that c squared plus 1 cannot be broken down. It's not factorable. We do not have a property that takes addition inside of a log to do anything with it. So this is as simplified as it's going to get. In this next problem, we have an exponent outside the log, which is going to come out in front. And so we're going to have RT times the natural log of 0.5. And that's as far as that one is going to get simplified.